case number 2. Case number 2, we're going to talk about accelerated states of motion. And this is known as non-equilibrium. And you're going to see that this is what we're going to spend most of our time on for the rest of the chapter. Non-equilibrium motion. So what do I mean by this? I mean this. If I speed up, slow down, or turn, if I do one of these things, then I know I am accelerating. And if I am accelerating, then I know that the net force is 0. So what we say here is that we say something like this. 1 is being forced to accelerate. A net force not equal to 0 means that 1 is being forced to accelerate. So the only thing we can say here is that now we have what? Not balanced forces, but unbalanced forces. So therefore, 1 feels something. 1 feels something. So when I say the word unbalanced, then that means 1 force is larger than the other force. That's what that means. So what we want to do here is that I want to go in and I want to look at what we did before, just so that I can compare them. So I'm going to come up here and I'm going to grab this picture right here. So what we find here is that this is what we found. So for equilibrium, motion, we see that the force of the hand must equal the force of friction. And so picture-wise, we really are saying this thing right here. Right? This is what we're saying right there. Now, for non-equilibrium, that can't be the case. Right? For non-equilibrium, what this tells us here is that the force of the hand cannot be equal to the force of friction. 1 has to be bigger. So what I'm going to do here is that I'm going to take this picture and I'm going to modify it. And the only thing that I'm going to modify here is I'm going to assume that what I'm doing now is I'm going to speed up. So what that means here, that I have an unbalanced force here. So what I'm seeing, that this is the force of the hand. So the force of the hand is bigger. And as a consequence, what happens? Since the force and the velocity are in the same direction, that means that the acceleration must be in the direction of that, and I'm speeding up here. So what this red is telling me here, so when I compare the force of my hand when I'm in equilibrium motion versus the force of my hand when I'm in non-equilibrium motion, what am I doing? I'm pushing harder this time. I'm pushing harder with my hand. And so if I start to look at these squares here, let's count these squares. So I see that this is 1, 2, 3, 4, 5, 6 squares. So let's say this is 6 squares. So then I'm going to go 2, 4, 6. So this is the net force. So I'm going to go 1, 2, 3, 4, 5, 6 squares. Then if I look at friction, you could see friction here is 2 squares. 1, 2. So what this tells me here is that the net force is what? Well, the net force in this case has to be the force of my hand minus the force of friction. So what we can see here is that the difference between these two is that the force of the hand is 6, the force of friction is 2, so therefore that's a 2 Newton force. So what does the block feel? And the answer, it feels 4 newtons of force. Not the 6 Newton force of the hand, not the 2 Newton force of friction. So therefore, the net force in this case is what? Well, when I look at my picture, let me erase that, sorry. That means what it feels then is it feels a force of 4 newtons. It's the difference between these guys. It's 4 newtons. And as a consequence, it's then going to accelerate in the direction of the velocity. So it feels 4 newtons of force and forces the block to accelerate. Right? That's what makes the block speed up here. So now that I've kind of gone over that briefly, I want to spend more. You know, maybe I should have said this here, is right, that this is really an unbalanced force. We can see here is that the net, that the, oh, look at that. I wrote net right there. That's wrong. I should have written what? The force of my hand here. So what I'm saying here is that the force of my hand must be bigger than the force of friction. That's what we mean by an unbalanced force. One force is bigger than the other.